Let's take a look at the next part, and we've got a line here for question 10, which is x minus y plus 4 equals 0, and that intersects with this curve here, and we've got to find where it intersects, basically. What are the points of where this intersects? So we're going to find the values of x and then substitute them back in to find the values of y, and that's really all it is. It talks about p and q here, but that's really not our concern so much. So let's take a look at how this plays out. So first things first, I'm going to make this into a more useful form. So I've got x minus y plus 4 is 0. I'm actually going to subtract everything out of the way here. I want to get rid of the x. I want to get rid of the 4. So minus x minus 4. X minus x is 0. 4 minus 4 is 0. I'm left with minus y is equal to minus x minus 4. So this is all negative. I'm going to multiply everything by negative 1, by negative 1, by negative 1. This means I've got y is equal to x plus 4. So that's nice and easy. Okay. So now I've got a useful looking equation, and I'm going to make that equal using the equivalence method of the simultaneous equations tactics. I'm going to make that equal to this thing here. So I'm going to have x plus 4 is equal to this, but I'm going to put this on the left side because it's got more components. So I'm going to say 2x squared minus 4x plus 1 is equal to x plus 4. So first things first, I'm going to subtract x from both sides, making that 2x squared minus 5x plus 1. I'm going to subtract 4 from both sides. So that is now going to be minus 4. 4 minus 1 is going to be minus 3, in fact. So I'm just going to rub this out and write minus 3 in there. Here we go, minus 3. Here we go, is equal to minus 3. All right, so this looks, let's have a look. What bothers me about that? No, that's fine. I'm just looking at what they've got, and they've got something very different. But that doesn't matter. We will be good. All right. Oh, no, wait. No, they've got the same thing. Okay, that's interesting. Okay, I've just taken a slightly different approach with the other one, but this one I think was about the same pretty much. All right, so let's just make this equal to 0, and let's solve for x. So we're going to have 2 times 3. Well, 2 times 3 is 6. We've got a 1 and a 6 and a 2 and a 3. But it can only be one of those because we've got a 2x here, a 2x here. Signs are going to be different, and the biggest one is going to be negative. And negative 6 plus 1 gives us a negative 5. So that's the way around it's going to have to be. So we can simplify this. We can divide all of this by 2. So this becomes x minus 3. And this is 2x plus 1 is equal to 0. So let's see how this works. Well, we've got x. So either we're going to put x is going to equal 3, because 3 and negative 3 is 0. Or, and I'll actually work this one out so you can see it happening, 2x plus 1 is 0. I'm going to subtract 1 from both sides. I'm going to divide 2 by both sides. This is already gone, of course. So I'm going to be ending up with x is equal to negative 1/2. So here are my two things I've got. I've got an x as a 3, or I've got x as negative 1/2. All right, next sheet of paper. Now, in this case, this is where their little bit comes in when they happen to say p is 3, 7. And the only reason that comes in is because we know that x is equal to 3. And we could find out if it was also 3, 7. And we could do it simply by putting it into the other equation we had, which was y is equal to x plus 4. Well, when we put that into there, we find that y, when x is 3, so when x is 3, y is equal to 7. So they were right. So one of the coordinates, therefore, is 3, 7. But we want to find the other one. So we could say when x is equal to negative 1/2, y is equal to negative 1/2 plus 4. And 1/2 and 4, suddenly we're going to end up with 3 and a half. So y would equal 3 and a half. So the coordinates hence are going to be negative 1/2, comma, 3 and 1/2. And that is the solution. So we've got, and by the way, this is what they called P. and this one here is the other one, which is that one which is going to have to be Q. And that is how we find the solution to all of that.